In this lesson, we're going to look at Pythagoras' theorem. Now, the theorem actually states that in a right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Now, that's actually quite a mouthful, so let's break it down a little bit, and we'll start with a right-angled triangle. If we put a square on the hypotenuse, and then squares on the other two sides, and then label the triangle lengths A, B, and C, we can actually show that the square on the hypotenuse has an area of C squared, and the other two sides will be A squared and B squared. Now, according to the theorem, if we take the sum of those two smaller squares, they should be equal to the square on the hypotenuse. In other words, A squared plus B squared is equal to C squared. So let's see if we can show that. We'll take that triangle and make multiple copies of it. So there's one copy here. I'll have a second, a third, and a fourth. I'll label the triangles. And hopefully you can see what I've created is a square inside a square. Now that white square in the center, that's actually the square on the hypotenuse. And we can see that that area is C squared. Now by moving the triangles, I can take that area of C squared and we actually create two smaller squares. And if I label my triangles again, I can see the area of that top square is A squared, and the bottom left square is B squared. So what we've shown is that A squared plus B squared, the smaller squares, is equal to the area of that larger white square, C squared. And hence, Pythagoras' theorem, A squared plus B squared equals C squared.